A moment, a moment. Wait. Great. Start all right. Sounds all right. Um, Hello, friends. Welcome to Soul Java channel with Nicolas. Nicolas, please introduce yourself.
Hi, everybody. Thanks for having me. So I will start the presentation because this is part of my presentation. Thanks to be for this talk about some performance improvements and also resiliency improvements in your microservices architecture. I'm Nicolas Fränkel. I've been working more than 15 years as a Java developer, architect, whatever. I've been a consultant for nearly all my career. So that meant I had to go to different customer, work in projects, face deadlines. And actually, after 15 years, I didn't like it so much. So what I did is last year, like 1 year and a half ago, I decided to do like my, let's say, my idols. I went to developer advocacy, and then I went to do like talks at conferences, write blog posts, do some videos, and some webinars like tonight. I work for a company called Hazelcast. You might know about Hazelcast. In general, this talk is much more interactive. So if at any point in time you might want to ask questions, please do so. Because right now I don't see you. I'm just talking in front of my screen, which is not super great. But, well, we are all confined, and so we must take other routes. So we have two products. Our first product is called IMDG. This is the goal, the target of this talk, so I won't discuss it right now further. And the other is Jet, and this is to do stream processing. So if you know about, let's say, Kafka streams, so we take data from one point and we put it somewhere else, but not just by batch only. We have a streaming API, meaning that the streams, the data can be unlimited, can be abounded. And if you know about, I don't know, like Java 8 streams, it's the same but distributed. And because it's distributed, we leverage Hazelcast MDG. I'm also quite proud these days because we are part of Google Summer of Code. So if any of you is a student and want to contribute to open source, either as a first-time effort or if you have been a regular, we will be very happy to see you. Just ping me afterwards and I will try to help you on board. But don't wait too long because it's only like until 31st of March that we accept proposals. Well, not we, but Google Summer of Code in general. So this talk is about improving your microservice architecture. And this is not my definition. This is Martin's Fowler definition of microservices. And if you read all the bullet points, I believe some of you might also already like believe they do microservices. I honestly don't understand why the hype about microservices. I think it's for 5% of the companies, it might make sense, but it's very dangerous. Anyway, if we go through all the points, like the first points, they are all about technology or design. This is within our control, and this is we as developer, architects, or team leads what we can do, and it's all fine. However, if we proceed up to the before last point, the organized around business capabilities, now it's a bit harder because now we must cope with the business. However, again, we can design. So if we have, I've worked in e-commerce and I use these e-commerce example a lot of times. If we have an e-commerce shop, we can design microservices, and one microservice will be designed around payments, the other will be about the cards, another one will be about the catalog of products. So that's still okay. Now, if I go to the last point is products, not projects. And the main difference between a product is a project is both have a start date, but projects have an end date. Products have no end date. In general, they can run for years and years and years and years. Whereas the project has an end date, and then you have a budget that is allotted for the project, whereas product, the budget is allotted yearly or twice per year or whatever. And I think that's the main difference. And if you apply this definition, actually not a lot of us are doing microservices, whether we like it or not, by the way. It's just the definition of Martin Fowler. If you apply it, not many organizations are able to do that, because we like to have end dates. We like to say that the budget is not recurring. The main benefit of microservices is scalability, and that's very important to understand that in that case, if I take the same example as previously, the e-commerce shop, everybody understands that if you have a funnel, it's a commerce experience. You start from browsing the catalog, then you put items in your cart, then you go to checkout, then you do the payments. And it's a funnel. So along the funnel, you have less and less people going. So you will have perhaps 100 people going to the catalog, perhaps 50 of them or 25% of them will actually put items in their baskets. Then perhaps 5% will go to checkout, and then you will have 1% going to the payment and doing the actual payment. And the issue is that if you have a monolith and you need to scale, well, you scale everything in the same way, but actually you don't need the payment so much. Probably the biggest hit on your architecture will be the catalog, because again, if you have 100 people going to the catalog, but only one going to the payment. So the main benefit of microservices in this context is you say, okay, now I break everything down into different applications, and I can scale them independently. So I can have 100 of nodes handling the catalog and only one node handling the payment. Probably for the payment, you will still have 2 nodes just to be sure and to have resiliency, but you see my point. Here, this is supposed to be a joke. This is, again, supposed to be interactive. Those are 2 UML diagrams that I show at conferences. And yeah, the question is, do you spot the difference? And of course, there are none, but for architects, one of them will be an API call, like something call inside the JVM, and the other one will be a microservice call. And for an architect, it makes no difference. The rest is just an implementation detail. But for developers, there is a lot of difference, because when you start going to the microservice way and you move from an API call to a network call, then you start going into the realm of distributed systems. And you must understand that when you start going to distributed system, regardless of failure or whatever, then you have the biggest hurdle. The first one will be, it will have a hit on your performance. So you started thinking, I will do microservices, and then it will be easier for me to scale. But when you start having microservices, then you actually decrease your performance a lot. And yeah, again, because network calls. But it's not only about performance. Actually, I love this slide. This slides, there is a reference, and I will actually publish the slides. This is something you should print and put where everybody can see it. Generally, it will be the toilets, but you can put it anywhere else. It's fine too. This is what we naively believe about the network. And the first is always very funny, like the network is reliable. When you do an API call, when you call an API inside the JVM, it can either succeed or it can fail. There is no in between. When you introduce the network in between, it can either succeed or it can fail or something else. And that something else is you made the call and you've got no response. And in that case, it's really bad because you don't even know if the service that you sent the request to received it or not. So you've got no response, but you don't know whether the service got the request in the first place. So you're basically like in the dark. You cannot assume anything. And that's the fun of distributed computing. And I mean, I won't go through the rest, but this is really, really interesting. So it's another world. And that's one of the reasons why you shouldn't be doing microservices eagerly, why you should be very afraid to go to that step. It's because all of this needs to be handled, either at a code level, library level, or another level, but this needs to be handled. It's very hard, it takes time, it takes money. And so this is more like a real microservice call. And the good thing is those layers in between, they can be seen as network layers, they can be seen as code layers, because in general you are not like making HTTP call by yourself. You must go through a library or even through a framework. And I mentioned the response. So this is what the previous call looked really like. And now that should be displayed, and that should be shown to your architects so that they understand that the previous diagrams, they are completely different. And now you understand that performance is impacted. You might still want to have good response time. And in that case, there is a trade-off involved. And the trade-off involved is, if you want, you know about caching. I mean, when you have a performance issue, in general, the first solution is to do caching. When you start doing caching, you must understand that you do this trade-off. Now you will get your response time very, very quick, but the data might be stale, might not be up to date. When we think about it, in general, at first, we say we want the data as fresh as possible. But when you think about it, in general, that's not really true. Like I mentioned the e-commerce site. So imagine you are in charge of an e-commerce site and you have your microservice architecture and you can scale independently, and you scaled like the catalog a lot of times, and now it goes down to the payment. And when you want to display the price to the user, you also have a dedicated microservice, a pricing microservice. So the catalog microservice calls the pricing microservice. Now imagine that every time, if you want to show the price, you need to call the service. It takes some time. And there have been studies that shows that milliseconds, or let's say 10 milliseconds, or let's say 100 of milliseconds, so tenths of a second, has a direct hit on your sales. So something that you think is not tangible, is not visible to the user, impact your sales. And if you are Amazon scale and you lose 1% or 2% of your sale, it's a lot of money involved. So you don't want that. And as I mentioned, there is a trade-off. So the other way is to cache the pricing inside the catalog. So every time you got the price, you cache it for a certain time. But that means that actually you are selling at the wrong price, and us as engineers, we are not happy with that. We must sell at the good price. But the business doesn't care. The e-commerce business doesn't care. The first thing that sometimes you might sell a bit too high, and sometimes you might sell a bit too low. But by the end of the day, everything will be average. So you don't lose that much money, if you lose money at all. And the second stuff is, in the e-commerce business, the most important stuff is to sell at, I wouldn't say any price, but nearly. Like you must sell, because if you don't sell, then customers will go to your competitors, and that is not acceptable. So pricing can be cached. It's not an issue. I mean, of course, you shouldn't cache it for like 2 weeks, but the trade-off is, okay, how long should we cache it? In general, you can cache it for like some time anyway. I mean, it's not seconds, it can be minutes or 10 of minutes. And the other example that came to me recently is banking. If I ask you whether you should like get a direct access to your accounts, that the accounts would show you the current balance of your account, I believe every one of you would tell me, yes, of course. But no banks work like that. Actually, when you have your app, when you check your balance, it's a front end, and the front end is the result of a batch of the previous day. So every time you go to your banking account, it's the balance of the previous day, because the operations of the day, they haven't been accounted for, the batch hasn't run. And everybody knows about it. And everybody is okay with that. So even a 1 day cache, even if it's not really cache, is acceptable in some cases. And when you start to think about caching, in fact, you can cache a lot of things, because the trade-off of fast versus fresh in general is very in favor of the fast. Of course, I cannot talk about caching without like quoting this stuff. Like, there are 2 hard things in computer science: cache invalidation, naming things, and off by 1 error. This is like famous quote. And if I tell you about caching, I believe everybody has already started at one point in his life to do caching by oneself. In general, when we think about caching, we say, oh, it's just a hash map. And I've been guilty of that as well. The problem is, a hash map is unbounded. So you put stuff into the hash map, and it grows and it grows and it grows and it grows. And if you leave the hash map hanging, then at some point it will take so much memory that it will be a problem. So when you think about that, you must first about the limit. How many objects at one time can exist in the cache? And afterwards, you must think, if we reach that limit, what will be the eviction strategy? Should we keep the most used objects? Should we keep the most recent objects? There are a lot of strategies available. And even if we don't reach the limit, at one point we might say, the data is stale now. We probably need to get it from the original source of truth. So you probably have a time to live anyway. And when you start adding everything, then it's very hard to create a caching solution by yourself. So my advice here, whether you use Hazelcast or not, don't try to do caching by yourself. Just use an existing caching providers. And there are a lot of open source providers that are also free. I won't, of course, list them, but you have a choice. Hazelcast is one among many. Hazelcast has this concept of in-memory data grids. Because once you have a cache, it's good if the cache is localized on each node, but it's even better if the cache is distributed so that, the memory among all the nodes is shared. So you can think about an in-memory data grid as a hash map, a Java hash map, but which data has been partitioned and distributed among all nodes in a cluster. And the good thing is that Hazelcast provides a convenient API. We have something that we call an IMAP, just because the name map was already taken. And it is just that. The API looks very similar to the standard Java hash map. The only thing is that there is a lot of distributed computing network call involved that we take care of for you. In these microservices worlds, I will show you 3 different ways that we can leverage Hazelcast and Hazelcast caching. The first will be database access. The second will be doing HTTP calls. And the third is not about being fast, but is about being resilient. And I will talk a bit about session data. My first case will be about Hibernate. I believe that Hibernate has been popular for a long time, and because of its long time popularity, it's still very popular. So there is still a lot of inertia. Of course, there is a lot of people saying that we should use ORMs, and if you don't want to use ORM, that's fine. But if you use, for example, GPA or Spring Data GPA, Hibernate is the default solution in Spring Data. And I remind you that Hibernate has 2 caches. The first is the level 1 cache, and it's by default. So this is at the session level. So if when you get the session and you do some data manipulation, whatever happens will stay in this level 1 cache. So if you, I don't know, put something in the database and you want to read the same entity, then Hibernate will assume that it hasn't been changed and will get it from the cache. That's good. But the problem is, since it's bound to the session, it's limited to the session's life cycle. And when you do a web app, in general, what you do is you open the session at the beginning of the HTTP request. And when you get back to the response, the session is closed at some point. So when a new HTTP request comes back, you've lost the session and you've lost the associated cache. Hibernate knows about it and proposes a second cache, what they call a L2 cache, level 2 cache. This is optional, so you need to activate it explicitly, and there are multiple integrations available. Again, Hazelcast is one among many. And cache reads works in a very simple way. When you read something from the cache, you give it the key. If it doesn't contain the key, then Hibernate will look into the database, get the data, put it in the cache, returns the value to you. If the cache contains the key, it returns the value that is already cached. And when you write something, then you either create a new entry in the map or you update the entry with the new value. Now it's time for some demo. If at any point you have questions, I don't know how you can signal it to me, but please do so. And this is something else. This is my microservice performance. I've created a simple application with Spring Boot. I hope everybody is familiar with Spring Boot. Here, I have my POM. I am using Spring Data GPA because it makes stuff so much easier. I have a web application. I'm using Hazelcast. I'm using Hazelcast integration with Hibernate, and I'm using an in-memory database, but it can be any other database, just simpler. I have some data already. So this file will be directly read when the application starts. I have this like stupid code. This is a Spring Boot application. I have a controller that actually will call a repo, and I have to mapping / will read all persons from the repo, and / ID will read the person by that ID. Now I have a person repository, and since I'm using Spring Data GPA, I didn't declare anything at runtime. Spring will create all the method implementation, and actually that allows me to do this find all or find by ID. It's a REST controller. So in the end, what happens is I can do some REST queries, and it will return me the right stuff. So let's do it. Everything works fine. Is it possible to optimize the principal slides? Okay, how you mean this? This slide, okay. Here you mean the code is too small, right? This is better? No, I understand your point. Okay, nope, I don't know how to do that. Okay. I understand how to stream and it doesn't look nice. Nope, nope. Let me try to change the resolution. Sorry about that. Thanks for the ping. Thanks for the feedback. And display. And I'm afraid it will be hard for me to do anything. I don't know how to do that. I see the problem. Now, if I do like that, does it works? No. Not great. Sorry, I will check how it looks in YouTube, and I cannot see anything in YouTube. That's sorry. I will check how it looks in YouTube, and I believe there is a refresh issue as well. Let's try that. Yeah, sorry, I'm afraid that I cannot do better. I will try I have a refresh issue as well. So, okay. Where was I? Yeah, I have this person repository. I've started the application. So normally I should have all those entities in my database, and I can start making query. However, in order to prove you beyond any doubt that it actually works, what I did is I added the Hibernate statistics. So here, for example, this is a statistics. Since I didn't do any query, of course, I have 0 everywhere. But now I will start curling, and I need to remember the endpoint. So the endpoint is /d. So if I curl http localhost 8080/d/1, it gives me the first entity, which is my friend Jandu. And in the statistics, we can see that because here the cache called, there was nothing. It was a cache miss. And since it missed, it puts the entity into the cache. Now, if I redo the same query, the statistics should tell me that there was a cache hit. Yes. And basically, there was no JDBC anything. So I went much, much faster in that case because I didn't go to the database and then back. I just got the data directly from the cache. What we can also do is we can read everything. Whoops. So now we've got our 3 entities. They are all in the cache. And if we query one of them, or any of them, by the way, since they are all in the cache, again, there is nothing to put again in the cache because everything in the cache, so there is a cache hit directly. How can we achieve that? The great thing is I've shown you that in the POM, we just add Hazelcast Hibernate, which is in the latest version, by the way. And afterwards, we just configure Hazelcast itself. Here is just to show you you can have an empty XML just but for the instance name. The rest is just for fun. And the most important is how do you configure Spring Boot? And you configure Spring Boot like that. So you say, hey, I want to use the second level cache. You use the query cache, and you say here that you want to use this like factory class. Then you can set the Hazelcast instance, and it's finished. That's the only thing that you need to do. And in just a few lines of configuration, now you've got directly caching. So you just improve your performance on the spot. If you don't like XML, because I know that a lot of people don't like XML, we can also have like this configuration with codes. And actually, it's very easy to do. So what was done in XML, I did the same here with, and with Spring Boot, it's already handled by the Spring Boot starter. So here, Spring Boot will see that there is a bean of type config, and will say, okay, that's how I will configure Hazelcast. So quite easy, great. Second point. But before the second point, I need to tell you something. This is great, but not optimal regarding speed. Basically, here we are still going to the database. And if you really, really want to be very, very fast, every time you go to the database is time lost. What we could do is that our code will only interact with Hazelcast in memory. And in that case, what we can do is every time we do a change to the cache, then there is an asynchronous task that will synchronize your cache data to the database. Now you are very, very fast. You are the fastest possible. But again, there is a trade-off, because if at any point there is a crash and everything is in memory, then you will lose some data. Again, it's a trade-off. It's not a silver bullet. If you want to be very fast, then you lose resiliency. Up to you. Second point, I already told you about my beloved e-commerce architecture, about all the services that need to talk together. And the thing is, all those services in general, they talk through REST endpoints, so HTTP and in general JSON. And as I mentioned previously, it takes a lot of time. An HTTP call is 1,000 times slower than just a JVM API call. So we want to cache the results. And we could do that manually, but actually there is a Java API for that. So we should use the Java API when something is great. And there is something called JCache. So perhaps you are familiar with JCache. And JCache is a specification, and you have multiple implementation. And again, Hazelcast is one of them. There are others. And the good thing is JCache is integrated with Spring. However, in that case, you have like JCache, again, then you have Spring Cache, and then you go. But actually, we can be simpler. Since I'm already using Spring Boot, I will directly use Spring Cache, because Hazelcast is a Spring Cache implementation as well. Let's see how it's done. I will stop that. I will go to version control, and I will directly go to Spring Cache annotation. And here I create the cache manager for Spring. Again, I didn't change the config at all. I've added a new, what I call a proxy controller. Now the proxy controller use what I call caching service, like is a layer controller and the repository, just to show you how it's done. But it's not very important. It can be an HTTP call, it can be anything. And here, every time I go to the proxy controller, then the caching service will cache the results. The caching service just say cacheable. That's the only thing that you need to do. And service is the name of the Hashmap, not real Hashmap or IMAP or whatever. It's the name of the cache. And that's all that you actually need to do. Now, let's start it. Now we don't care that much about the Hibernate statistics. It's proxy, it's R. Don't ask me why, I don't remember. And now how I'm supposed to show you that it actually works. I'm afraid that it's hard to do without showing you our management center. So far, everything that I showed you is completely open source and free. our management center is part of the enterprise offering, so you need to pay for it. But because here I have no other way to show you, I need to here I will start the management center. So I start, and I will start it on port 8081 and at the root. Now I can go there. And now please. Yes, I still don't know how to do it. I can expand the window tab, but I don't know how to do it. That's the best I can do. And now I need to remember my login and passwords. That's the hardest thing to do, actually. No. Yes. And here, it's a bit big. Here, we can see the cache, actually. And we see that this service as one entity is probably the one that was put when I made the first call. So we see that there was one get, there was one put, and so far there's been no hits because I didn't query it again. So let's query it again. And if we wait a bit, we will see that there will be one hit there. Yes, so now perhaps it's not refreshed on your screen, but it is on mine. I have one hit, and I have two gets. Now you still only have one entity in it. So I will try to query for another entity. And normally, after some point, you will see that the management center is refreshed, and we will see there are two entities. And of course, we have three gets, and we have two puts. Now, graphic should change. And yes, we can see now that there are two entities. Great. The only thing that we cannot do compared to Hibernate is we cannot try to have all entities in the cache. Sorry, up. I didn't do it because actually, sorry, this caching service, we cannot put a list of objects in the cache. Is that with Hibernate, knows about an entry, it knows about the primary key, and it knows about the entity. So primary key will be the key in the cache, and entity will be the value. The problem with Jcache or Spring Cache is here, it's the same, but actually if we do a get all, there is no way to put that with an annotation in the cache. So we would need to populate the cache by hand, by ourselves, which is not super handy. So no, put everything into the cache at once. Next and last point, session data. Everybody hates state. I mean, we always have been told that we should go stateless as much as possible. And the problem is as much as possible. At some point, you have state. You must have states. There is no way not to have states. And the biggest state generally is session data. So this is a very simple architecture. You have an HTTP load balancer in front, let's say Apache. Then you have two Tomcat nodes, and then you go to one node or to the other node. If you go to one node and then to the other node, the problem with that is you need a way to synchronize the data, which is not great. Every time it will take time. So what you what we have been doing for ages is we say once the load balancer has associated some session identifier with a node, every time comes the same session identifier, then the request is balanced to the same node so that the session stay on the same node and session that as well, and everybody is happy. Well, everybody is happy until the node fails. And it's not if it fails, it's when it fails. So we want, even if we are doing sticky sessions, we want to synchronize session across all nodes. And then we have no standards, no JCache, no nothing. Everybody does what he or she wants. But Hazelcast has a lot of integration points to help you with that. You can have a filter-based solution. You can have a Spring Session integration. You can have direct Tomcat integration, either on Tomcat if you are deploying on Tomcat as WARs, or through Tomcat embedded with Spring Boot, or the same with Jetty. And this will be my final demo for tonight. I will stop that. I will go to the latest thing. Check out more. I will close everything and then show it again. So now, sorry, the application has another controller, and what the controller does is actually it will get something from the will increment it. So this session data handler here is just that I put in session. It has two attributes. It has an ID, and the ID will be the session ID, the like JSession ID, and then I will have a counter. And I will distribute it over two nodes, just like in the slide. And what I want is to have a load balancer. And in order to prove beyond any doubt that it works, I have this HR proxy configuration, and the HR proxy configuration will do round robin. So every sticky session, it will balance to the other node. I have a Docker Compose file. And so I will have these loads using these HR. And I will have two nodes with the same application that I've shown you before. And my point is it should increment the counter. If session replication, every time I will go to a new node, but since the session will have been replicated, then it will increment the counter. If I didn't do proper session replication, then the first time I go to a node, then the second time I go to the other node, and the counter will be the same. It will be even or odd every time. So I will stop the management center. I will go to microservice performance, and I will Docker compose up my solution. Now it starts every image, every container. So you see that the two nodes are in the process of being started. So like the load balancer is with two nodes to be up. And normally it should be okay now. Here I can close this tab. Here I will say localhost, and it's session. Yes. Okay, so this is my JSession ID, and the first count is 1. So now you can see I'm going to refresh the page once. And if I told you the truth, then it should tell me 2. Yes. So here I went to another node, to the other node actually, because there are 2 nodes, and still it incremented the counter with 2 because 1 was already present because we have been doing session replication. Now it should be 3, and now it should be 4, blah, blah, blah. The code is like that simple. Again, Hazelcast takes a lot of stuff in charge. The session code replication is here. And this is the snippet. Since I'm using Tomcat MBA, configure it with Spring Boot, and what I'm doing is I'm Hazelcast Session Manager. Here, forcing no sticky set. I must tell it that to synchronize every time and to set sticky to false. But normally you can set sticky to true. Then it allows you to do a lot less locking, and performance is better. And of course, I'm using the Hazelcast instance name that was created previously, and then I set the manager into the context. This is the only thing that is required. It's really very, very simple to use. Getting back to the presentation, because you might have stuff to do, finish at some point. The takeaways of this talk are: be very careful. Scalability and performance are not the same. You are going to use microservices to be scalable, and it will directly impact your performance at first. To get back to the same performance as before, you will need a lot more nodes, and it's going to take more time, more money, more resources. If you want to counteract those performance hits, of course, you're welcome to use caching. But again, it's a trade-off. If you use caching, then you will have stale data. As I try to show you, stale data is acceptable in a lot of cases, but not in every case. So it depends a lot on your context. Finally, Hazelcast IMDG provides a lot of integration points into frameworks, into servlet containers at different levels. And so we can help you coping with that at all those different levels. Thanks for your attention. You can read my blog, you can follow me on Twitter, and more importantly, you can get the repo and see for yourself how easy it is. So now I believe that my talk is finished, and if you are not bored with me, then I might have time for some questions. Oops.
Hello, friends. Questions? No questions.
I'm always afraid when there are no questions. So thanks a lot for your welcome. Thanks to I've made my evening much better, because I mean, I'm like you, I'm stuck at home. It's very, very boring. If you were too shy to ask the questions in person, just ping me on Twitter, send me a direct message. I will be happy to answer. And I wish you a very good day and hope to see you in person someday. Bye.
A moment. One question.
One question. Okay. What exactly can I explain? That's a good question. What can I explain in more detail? What was not clear? like I will try to repeat, and then you can ask question of what was not clear. Actually, by default, you have level 1 cache in Hibernate. So you have your session factory, you do get session, and whatever changes you make to the database through this session, they will be cached into this session. So if you create a new entity, for example, for this session, then this new entity will be, of course, at some point synchronized into the database, but it will the point you want to put forward. Alors, I will show you my code example. This is it. So level 1 is activated by default. So actually level 1 cache, you don't need to do anything. Level 1 cache is what Hibernate does for you. As I mentioned, the problem with this level 1 cache, it's bound to the session. And since it's bound to the session, when the session closes, then your cache is fresh again. And the problem is my code example, well, every time you use Hibernate, you will use level 1 cache anyway. That's the basics, whether you want it or not. It's how Hibernate works. The issue comes is this level 1 cache has a very short lifespan. The cache, the level 1 cache, has the lifespan of the session. And the problem is because the session has a very short lifespan, so every HTTP request creates a new session, then this level 1 cache has the same lifespan. And so basically, if you do another HTTP request, then basically the cache is empty again. So it's no use. In order to leverage second level cache, you must tell it, hey, use second level cache, and tells what second level cache you want to use. And it's all. And at that point, I didn't use the L2 cache explicitly. I'm configure it. And because Spring Boot is integrated with Hibernate, and Hibernate has been configured with Hazelcast, suddenly, magically, I'm using L2 cache. And as I showed you, by showing the statistics, I was doing two different requests, two different HTTP requests, and still I had cache hits, which was great, which was what I wanted. I hope I answered the question.
Okay. Friends, more questions? More questions?
Great. I'm happy you got it. Okay.
Okay.
Then have a good day. Thanks a lot again for your invite, Daniel, and hope to see you soon.
Oh, thank you.
Bye-bye.
Bye.